Hello, today we are working on math packet number 9. Our first page says Bob's Super Ball bounces exactly half the height from which it is dropped. He drops the ball from the top of a building that is 64 meters tall. How high will the ball bounce on its 8th bounce? So it's starting at 64 meters high. This is not its first bounce. That's where it's starting. So its first bounce, it bounces halfway up. What is halfway of 64? 80. 32. So this is bounce number 1, is 32. Then it comes down and it bounces halfway up. What is halfway? 16. Thank you, Aiden. So that is our second bounce. So you need to follow that through all the way to the 8th bounce. Again, very important, it starts at 64 meters. That is not the first bounce. Your first bounce is down here when it bounces up to 32 meters. So when you're counting your bounces, you want to go all the way to 8 bounces. So you start your first bounce is the 32 meters.
Wait, wouldn't it just be?
You're going to keep going down, getting half, until you get to the 8th bounce. Luciana?
And then you just count like the amount, like 3 or 5.
So whatever the height is when you get down to the 8th bounce, that is your answer. That's how many meters it bounced. All right, our second page. Second page. A florist is making identical bouquets from, thank you to my friends who are not talking. JT, do you have your packet out? You got it last week. A florist is making identical bouquets from 36 tulips, 27 roses, and 18 lilies. No flower should be left over. What is the greatest number of identical bouquets that the florist can make? And how many of each flower will each bouquet contain? So your answer, you're going to have how many bouquets? And then how many tulips will be in one? How many roses? And how many lilies? So I should see 4 answers for your answer. How many bouquets altogether, and how many of each type of flower in each bouquet? The way to find this is the GCF. Who remembers what GCF is? Melina. Greatest common factor. So we have 36, 27, and 18. You need to find all the factors of 36. So we know it's going to be 1 and 36, 2 and 18, 3 and 12, 9 and 4, and 6. Those are all factors of 36. So I have the factor with its factor buddy all listed out. Then I'm going to list out all of my factors of 27. 1 and 27, 3 and 9. Those are all my factors of 27.
That's it?
Then I need to do the same for 18. List out all the factors of 18. How do I find my greatest common factor? I'm going to look at which factors that all 3 numbers share. And I'm going to circle the biggest one. The biggest factor that all 3 numbers share is going to be how many bouquets I make, that greatest common factor. And then the individual flowers, it's going to be its factor buddy. So if I had 10 and 15, if those are my 2 numbers that I'm sharing, my factors of 10, my factors of 15. I would find the biggest number that they share, and then its factor buddy would be the flowers. So if I had just daisies and begonias, let's say this was daisies and this was begonias, I would make 5 bouquets. There would be 2 daisies in a bouquet and 3 begonias in a bouquet. So I look at the greatest common factor, then each individual flower amount is its factor buddy. So let's look at our next page. Next page is that 5-card challenge. All of my equations should equal 1. Remember, there should only be one equal sign in our equation. So make sure as you're working it through, you're doing that. You can work it all out. 5 plus 3 equals 8, plus 2 equals 10. But you don't write that for your final answer. You take out those equal signs. 5 plus 3 plus 2 equals 10. Okay? So only one equal sign in the equation. This time they should all equal 1. That ace has 1 heart on it, so it stands for a 1. So aces equal 1. Next one is our patterns. So we need to complete the table for the total blocks in each figure. So I really don't care if they're purple or green. I just need to do this column. And I need to do the full column down. So if I look at my first figure, figure 1, how many blocks are there in it? Anybody?
9.
9. How many blocks are in figure 2?
36.
How many blocks are in figure 3?
81.
And how many blocks are in figure 4?
26.
How many?
26. What?
Nope.
Hold on. Leave me.
So in order to find it out, because it's a square, I can do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And I know there's going to be 12 going down. So it is 12 times 12, 24. And look at that. Our shapes
60.
are perfect squares. So that means our answers are, my favorite numbers, perfect squares. Perfect squares seriously come up all the time in these pattern blocks. What is my square for 9? 3 squared. How do I get 36? 6 squared. How do I get 81?
9 squared.
How do I get 144? Do you see a pattern?
Yes.
Look for the pattern, 3, 6, 9, 12. Figure out what comes next and square it. Figure out what comes after that and square it. So when we do these pages, find the pattern. Okay? So you're just going to follow that pattern down for 5, 6, 7. We don't have to do that bottom box because that's just for geometry. Next page. We don't see something that says Math 6, but we do see all classes. So we just have to do the all classes. It says draw a net of the figure and label its sides. So remember that net is cutting it open and laying it down flat. And you're going to be putting the measurements for each side. So if we don't know it, it's that X, right? We know this is the 5, this is the 9. So when you cut it open, be figuring out which sides are all the 5s, which sides are all the 9s, and which sides are all the X's. Next page. Oops. I will be giving us our formulas, and Mr. Schultz gave us some numbers to fill in to make some of these a little bit easier. So our formula for our rectangular prism is length times width times height. So write that in. We're going to put our base length as 3 and our height as 20. And we know that that full volume is 60. So remember to figure that out. We're going to put in the numbers that we know. So length is 3, the width we don't know. We know our height is 20, and that equals 60. Do your opposite operations. If we're multiplying, you're going to want to divide to get down to being left with what your width is.
So how
You're going to do the math. Formula for our square. It's that same length times width times height, but remember, that is also side cubed. It's the same number when it's a cube. So side times side times side is the same thing as length times width times height. Remember, we are multiplying these, not adding them. So what number can we multiply by itself 3 times to get to 27? We're not saying the answer. If you know it, fill it in. That's an easy one for you to do. If you want to do the triangular prism, it's 1/2 length times width times height. And we're going to have a length of 3 and a width of 10. If you're going to do the pyramid, it's length times width times height divided by 3. You can do a width of 2 and a height of 3. The cylinder is pi r squared times the height. And we're going to use a radius, that r being 2. Our cone is pi r squared, height divided by 3. We're going to have that r, our radius, be 9. And our sphere is 4 divided by 3. Let me write that a little better. 4 divided by 3 pi times r cubed. So for Math 6, you only have to do 2 of them, but I encourage us to challenge ourselves to do more. This will help us with our geometry. It will help us when it comes time for that math test. It gets us comfortable doing these formulas, learning the formulas. Riziki.
will we get extra credit or no?
We don't get extra credit for this one, no. You just get the extra knowledge and extra learning. So that is your bonus, is extra learning. If we didn't fill them all in, that's okay. You can watch this video later to get them. Let's look at our last page. Second to the last page. So remember, when we get these kind of pages, the first thing we have to do is find our full area, so the full shape. Then we have to find the white area and subtract it away from that full figure to get our shaded. So what you're doing is you're finding the full figure. So full figure minus the white figure, and that's going to equal the shaded. So find the area of the full, subtract out the area of the white, and you're left with your shaded. So our area of that full square, because it says that it is a square, so the area of a square equals length times width. The area of our white circle equals pi r squared. Going from this end to this end straight through the middle is our diameter. The diameter is 10. How do I find the radius, the r? Who remembers what the radius is? Super close to knowing, aren't you, Amelia? Anybody remember what the radius on a circle is? If from this end to this end is the diameter,
It's the
nope, that's the circumference.
it's the height.
You go from the middle
Oh, it's
to the end.
It's the height. I think.
Well, it's the middle to the end because it's flat. It doesn't go up. So what would our radius be on this circle? James?
360 degrees.
No. The degree measurement on a circle is 360. But guys, watch. If this is our diameter, is 10, our radius is from the middle
5.
to the end. So it's going to be 5. So your radius equals 5. So you're going to plug that into your formula. Pi times r squared, r is 5. That's going to give you the white figure. So our circle is the white. You need to find the full figure, subtract out the white figure, and you're left with the shaded. James.
So you do basically 3.14 times 5 squared.
So that is the area of your white. It does say round to the nearest hundredth place. So it is okay if you get a decimal. You're gonna round if it gives us a long number. So it's okay to have a decimal. Okay? If you do the 3.14, you're just going to the 10th place. If you do the full pi on your calculator, the symbol, then you're going to see longer of decimal and you round to the 100th. All right, last page. In this page, it's important to listen to the detailed directions I'm going to give you. We need to create a graph that represents all the data shown. And we need to use correct labeling. In order to get full credit, we have to have all of our labels on a graph. You are not going to get full credit if you just show me partial labels. A full graph has a title. What do you think a title for this data would be? Aiden.
Injuries.
Injuries. So you could just use injuries as your title for your graph. What am I going to put on the bottom? James?
One of the numbers and frequency.
So I'm actually going to put that on the side.
The names.
So on the bottom, I'm going to put my title for the bottom, which is injury type. And then I'm going to put each injury type across the bottom. You need to have your title for the bottom. You need to have a title going up. What would be the title going up? Frequency. So we're going to put frequency going up the side. You need that title going up the side, and then you're going to put your numbers. How high do you think our numbers need to go up to, Enzo?
14.
14, that's our biggest number, so our numbers need to go up to 14. Then you're going to do, you could do a bar graph for each injury type. To get full credit, you need all of your titles, plus the names and the numbers going up, and you need to graph them correctly. So you need to do a complete graph with correct labeling to get full points. Make sense?
Yes.
All right. So with that, have fun with your math packet. If you continue having questions,